Good afternoon, everybody. Great crowd, good energy here. Definitely think it's safe to say the reInvent is back. This is my 5th reInvent. Joined actually in the partner organization, so my first time being at reInvent is a service role, so super excited about that. Quick introduction. I'm Ben Perrick. I lead the product and developer advocate teams for several of our infrastructure as code solutions, namely CloudFormation, CDK, some open source tools, CFN Guard. And with me I have...
I'm Tatiana Cook. I'm a principal product manager, and I lead the product team for AWS Proton.
Fantastic. Cool. Okay. So this is Infrastructure as Code Year in Review. So of course we're going to be talking a little bit about what we've been working on this year. We're going to kickstart things with just giving you a view of what we see as our Infrastructure as Code portfolio. I think a lot of people just kind of associate Infrastructure as Code with just CloudFormation. And we want to kind of talk to you a little bit about that. We're more than just CloudFormation. There's quite a few different services that are actually built on top of just our core CloudFormation engine. And so we'll give just a quick overview of how we view our Infrastructure as Code portfolio. And then we're going to spend a little bit of time kind of opening up some kind of inner details of what we're working on. And this is around the resource foundation layer. This is probably an area where it may not be the most exciting new features, and quite honestly, the things that we're working on here are intentionally supposed to be transparent to you as customers. But we thought it would be important for us to make sure that you have an idea of what we're working on, because it's really critical kind of strategically how we're going to be building out our roadmap moving into the future. And then we're going to shift gears a little bit, and Tatiana's going to talk about some of the trends that we're seeing in the industry, trends around how enterprises are using infrastructure as code at scale, how personas are evolving, and who's responsible for infrastructure as code. And then as more and more customers standardize on using infrastructure as code, it becomes this really intuitive place to implement best practice checks and shifting left in policy as code. So we want to share some details what we have going on there. And then we don't want to all just be backwards looking at what we've done year in review. We'll spend a little bit of time giving some insights into directionally where we're going in 2023. Let's get started. So you all are here because you have some interest in infrastructure as code. But you probably didn't start using infrastructure as code. If you're like most customers, you started by maybe tinkering in the console, you started using a service, learning about something, maybe you deployed a single workload, you had 1 or 2 people managing your environments. And that worked when you only had a few people touching a few workloads. But as you started to add more people, you started to add more workloads, managing that becomes quite difficult. And so you start to search for ways to automate how you're actually going to be provisioning and managing the lifecycle of that. You wanted to have consistency, repeatability, security, safety in these deployments. And so you likely led yourself to some sort of an infrastructure as code-based solution. And so the way that our customers are using infrastructure as code, again, not always just through a traditional way of CloudFormation. Today we have more than 1 million customers using infrastructure as code, which translates into a CloudFormation stack. They author these templates using different forms. Maybe it's a abstraction like CDK or SAM. Maybe they're using services like Control Tower, not even realizing that deployment's actually happening using infrastructure as code under the hood. And then again, as I mentioned, as they're starting to see this pattern of everything flowing through infrastructure as code, they're starting to use toolings and find ways to implement best practice checks. And the last, what many people still don't know is AWS infrastructure as code tools isn't just about AWS services. We're actually a very open platform. We allow for you to be able to build different types of non-AWS services. And so we're starting to see more and more customers using our tools to be able to manage those other types of solutions that are critical to how they manage those workloads. So when we view our portfolio, of course, we start at the bottom with just AWS services. These are all AWS services have their own set of control plane APIs. And the first layer that we have is what we call the CloudFormation Resource Registry. This essentially is a set of resources that allows you to be able to define what you want in your template and translate that definition into a set of API calls against those individual services. So the foundation of our whole portfolio is this thing we call the CloudFormation Resource Registry. The slide deck will be available, absolutely. Yeah, they'll be available as part of the overall reInvent. So on top of that resource registry, we have our CloudFormation core engine. This is our core orchestration provisioning engine. What many of you kind of associate with infrastructure as code. Customers interact with our core engine using a JSON YAML-based template approach. And to meet the needs of our different personas, as I mentioned, Tatiana will get into more details, we're starting to see more different abstractions built on top of just core CloudFormation. So this is things like CDK, if you like to be able to use a construct programming model or perhaps author your infrastructure using something like TypeScript or Python. Maybe you have a specific type of workload, serverless, and so you're using something like the Service Application Model or SAM to be able to generate those CloudFormation templates. And then we have, again, another set of services on top of that that are helping customers do the deployment and management of how you actually scale out this infrastructure as code. So those are things like AWS Proton or Service Catalog. On the right-hand side is something that we launched last year. And this is going back to this idea that all individual AWS services have their own set of control plane APIs. We realized that there's an opportunity for us to create one standard API model, and it's built on top of this CloudFormation registry. So historically, how you would always just interact with the resource registry using a template, we said, why don't we just open that up and provide a control plane so customers can directly interact with that registry. And it opens up a lot of exciting opportunities for us. And we're going to get into a lot more details on some of those opportunities. But to start, really, we wanted to focus on this resource foundation. Again, it's something that many of you may not see some of the work that we've been doing here, but it's really critical for, again, how we proceed to our future roadmap. So just a quick story about this photo. This is a project my mom had at her house. She was adding a little room addition. And I have 3 boys. I have a 9, 6, and 4-year-old, and my oldest was kind of jumping in and out of this trench. And he asked me, he said, Dad, why is this hole so big? What's this hole all about? And then why is all this metal in there? And I said, well, that's what Grandma Joe's going to pour concrete in there, and she's going to build this foundation so she can build her new room addition. And inquisitive little kids, of course, kind of looked up at me, blank stared, and said, wow, it must be a heavy building. And the reason why I use this story is, when we look at our resource foundation and going back to that layering approach, it really starts with that strong foundation. We can enable not only internal AWS services, but also our partner solutions to be able to build those services and features on top unless we have this really strong resource foundation. And the importance of this foundation, first and foremost, we hear all the time, if a service isn't covered through infrastructure as code, it doesn't exist in our world. People standardize using infrastructure as code. They don't just give open access to their production environments. Everything comes through infrastructure as code. And so if you don't have a service supported through infrastructure as code, I can't even use it. So for us, we bear the burden of ensuring that all of these services that you all want to use every single day are supported through our tools. So most importantly, we have to ensure that we have coverage. And this is difficult. This week alone, we're going to be launching all kinds of new features and services. We have 200 plus services. Last year, we launched over 3,000 features. These are features, maybe it's a new API, maybe it's a new property of an API, something that requires infrastructure as code support. And if we don't have that support, you're not using those features. So it's really critical for us to ensure that we have support for all of these AWS services. And most importantly is this is something and a responsibility that we see is not just how we solve this for AWS in our internal AWS IAC services, but for the entire industry. We consider this a treadmill, right? We launch a new service, we have to have coverage. If we don't have coverage, we can't use the service. And it doesn't matter, one of our core tenets is it shouldn't matter what infrastructure as code tool you use. You shouldn't be prevented from using a service you want based off of your infrastructure as code solution. So our objective is to solve this resource model for the entire industry. If you use Terraform, if you use Pulumi, if you use some other solution, you should be able to ensure that the service you want is supported in that tool. So we take that responsibility of kind of solving this resource platform for the entire industry. So I'll give a little bit of background of what we mean by our resource and kind of how we got where we are. So going back 10 plus years, I don't know how many of you realize CloudFormation's been around 11 years. It's remarkable. But if we go back in time, when CloudFormation first came out, we owned the resource model. This means if there was a new EC2 feature that came out, we'd have to collaborate with EC2, and our engineers would have to go and build that coverage. And that was really great because it ensured that whatever we built worked. But as you can imagine, going back to that innovation machine that kicked in, we quickly realized we weren't going to scale in this model. There's too many things being built. And then we heard from you all and customers that said, hey, CloudFormation, where's the service support for this? And so we had to find a way to help with the scale problem. So we decentralized the ownership model of the registry, of the resource layer. We allowed service teams to build these resources. And that was great. All of a sudden, we started to fill this gap of not having support for these different services. But it led us to kind of the next problem. And the next problem was what we call consistency. So the best way I could describe consistency, how many of you are all familiar with features such as like drift detection or resource import in CloudFormation? Okay. So how many of you have gone to use drift detection and quickly discovered that that one critical service that you wanted to be able to evaluate drift in wasn't supported in drift detection. It's a common thing, right? How about maybe you had that one stateful resource where you wanted to be able to import that and to start managing that using CloudFormation rather than recreating it, only to find out that that service wasn't supported with resource import. It's frustrating, and we hear you. And so critical aspect of standardization is consistency. So when we decentralized this model, service teams started building. They started building, but it wasn't consistent. So features that we were trying to offer to customers didn't work. And we started to have this degradation. And we realized, well, that's not going to work either. We've got to come up with something better. And that's when we launched the CloudFormation Registry. The CloudFormation Registry provides a consistent resource definition. It's a schema-based model. Every single resource has to be published with a create, read, update, delete list handler, have strict contracts to ensure that they meet this standard specification. And when resources are built to that model, everything just kind of works. So things like drift detection, things like resource import just work. It allows us to have a much more exciting roadmap. So features such as automatic template generation can work because those resources are all modeled and built the same way. We're also able to kind of light up a lot of additional services. So many of you are likely using CDK, and with the standard resource model, we can auto-generate your CDK constructs. AWS Config uses the CloudFormation resource model to be able to provide config support. So all kinds of magic happens once you start to have this one consistent resource model. And that's what we call the journey to standardization. It's something that we've been working on now for about 18 months. Again, the intent here is that you shouldn't know that this is happening. It should be fully backwards compatible. We strive to ensure that if you launched a stack 4 years ago and you want to update that stack, it's just going to work. Nothing should be breaking for you. We don't introduce breaking changes. And so we've been evolving and migrating more and more resources to the standard model. And we have a little bit of work to do here. But again, we wanted to share this with you because we feel it's important so you know what we've been working on. Now, once we have a standard resource model, this gets really exciting. So we launched last year something called Cloud Control API. As I mentioned, Cloud Control API provides one standard API interface. In some ways, you could think of this as perhaps the AWS API. Today, if you want to interact with the service, you have to go and you have to understand what the specific syntax of the different APIs. Maybe it's a describe here or a get or a read there. You had to go and look at the documentation for those specific services. With Cloud Control API, you now have one standard set of create, read, update, delete list CRUDL operations or control plane operations for all AWS services that are supported using this registry model. And so we're exposing this standard resource model. People think, how the heck does CloudFormation tie into an AWS API? This is how. We have one standard resource model. It's abstracting those underlying APIs, and then we are able to provide that set of control plane on top. And it opens up lots of exciting things, lots of opportunities for automation. And one of the first automations that it opened up is going back to how do we solve this resource model for the entire industry? So when we launched Cloud Control API, we worked with some of our partners like Terraform or HashiCorp and Pulumi and Ansible, and they've actually built providers that interact with Cloud Control API. And what's this mean for you? It means this week, when we launch all these new fun, exciting features, those service teams are going to be building those resource coverage using that standard model. It means that we're going to expose that standard model through Cloud Control API, and it means that these partner solutions, their automation is going to kick in, and they're going to have support for those services almost on day one. We like to say on day one, but it's almost on day one, depending on when the automation is. So that's how we're solving this resource treadmill for the entire industry. It's a build once, consume anywhere model. And we're really excited about where this can go. Now, we want to give a couple updates of what's going on in recent launches. So the first one, I can't stand up here and say, oh, here's all the new resources that are supported by AWS IAC solutions. We add resources, close to 1,000 resources. So I'm not going to sit here and say, here's everything that launched this week. You expect that when those things launch, they have CloudFormation support. One that I do want to call out, though, is support for AWS organizations. This is something that customers have been asking for a while. And so we're excited to finally be able to say that of the few remaining services that don't have CloudFormation support, we now support AWS organizations. So now you can manage accounts, you can create organizational units, you can manage policies, all using CloudFormation. So that's one specifically. Again, not going to call out all the individual services that were launched with CloudFormation. This one we think was important. In addition, as I mentioned, CloudFormation, that standard resource model, when we were doing that for our internal teams, we thought to ourselves, well, we have the tool, we have the registry, why don't we just open that up? And so a while back, we launched this idea of the CloudFormation registry. And we opened that to partners so that they can actually publish their resources. Our customers are telling us that, hey, when I build workloads, I don't just build them using AWS services. I have a third-party monitoring tool. I have a third-party security tool. I use a different identity provider. So I need to be able to manage all of those different solutions that kind of circumvent or go around that workload. And so we're happy to announce that we just launched 50 new resource providers across some really well-known solutions. In addition to existing providers like Datadog and Mongo, we now have support for solutions like Cloudflare and GitLab and PagerDuty, et cetera. So if you're using these different solutions in your environments, we encourage you to go take a look. These are all, again, on the CloudFormation registry available to you. It's different than having to go and deploy a custom Lambda-backed a custom resource. These are on the registry. They act just like a native AWS resource. So if you want to do things like drift detection works when you use different third-party solutions like PagerDuty. We're really excited about it. OK, so that was a little bit of time just on kind of the foundational level again. These are things that may not be as exciting to you all, but we thought it was important to just kind of share what we're doing here and why we're doing it and how we're trying to drive to the standard model, try to solve some of these big problems kind of at scale. But now we want to switch gears, and we're going to turn it over to Tatiana, and she's going to talk a little bit more about what we're seeing in terms of overall industry trends.
Great. Thanks so much, Ben. Updates coming from CloudFormation team in terms of resource coverage. Many of you here are probably hardcore infrastructure as code users. It's something that you're adopting within your organization. But what I'll be talking about a little bit is how you can make sure that your people processes and the way that you as your organization are structured are supporting full use of infrastructure as code and allowing you to really take advantage of the benefits that things like CloudFormation, CDK, SAM, infrastructure of code use can provide. So I'll first be talking a little bit about some of the trends and areas of interest that we're hearing from our customers that we're talking about within service teams. And then I'll provide some updates from services like Proton and Service Catalog about how you're going to start seeing those trends reflected in the features that we launch. So the first thing, and I'm sure many of you here are thinking about it and talking about it, is this idea of platform engineering that's emerging as a practice and an area of expertise within a lot of organizations. And some of you may actually wear a platform engineering hat as part of your functions within the organization that you sit at. This is something that we're hearing as kind of a new way to think about some of the functions that a central IT or a cloud center of excellence may once have performed. And a lot of that is being driven by the idea that as you adopt things like infrastructure as code as a technology that's widely used and adopted, you need to figure out the right interaction models between people who are really cloud experts and who have deep knowledge of how to build the right infrastructure as code with security and deployment best practices baked in. How can you surface that and then support application developers who may be building something super cool and industry or domain specific, but they don't necessarily want to have to build deep knowledge of CloudFormation or have the expertise to understand the best way to implement a security feature within their deployments to AWS or other clouds that you're looking at? So really seeing some of this balance between application developers who want to build great apps and potentially influence some of what their infrastructure as code looks like, and then the team, the platform engineering team, who's building standards and building best practices. And we hear from a range of different sets of balances, and I'll be talking a lot about the fact that for each of you listening today, your organization is probably facing different operational constraints than peers from a different organization sitting next to you. There isn't going to be a one-size-fits-all solution. So one of the things we wanted to leave you with coming out of this conversation is taking a moment to reflect and really think, how do I make sure that my organization and operations reflect the kind of technology that I'm using and the best kind of operations for the business that I'm in, the industry that I'm working in. We're seeing this evolve in some areas like serverless as an example. If your organization is adopting more serverless technology, that may mean that you have to think differently about the process of getting an application from your test dev environment deployed out to production because of the way that your application and infrastructure are more tightly coupled together. So if you're using SAM, you may also want to think about a different kind of CI/CD process or check-in between your platform team and your application developer. Are you making sure to revisit the way that your operations are set up so that that technology can be implemented in the best possible way? And that's really something that we hear. Folks are looking for the right fit and the right mix of tools so that their organization, technology, and processes all work harmoniously together, and you don't end up with kind of a transplant of technology onto a development team that rejects the transplant. Some of you may have been part of initiatives to really push folks in one direction, and if you don't have the right operations and pathways set up, that can be really challenging and stressful for both teams involved. So we'll be covering a bunch of different kinds of technologies and services we have, and these 3 examples here, Amplify, Service Catalog, and Proton, all support different kinds of operation models. So if you think about something like Amplify, that's really designed for front-end and mobile app developers to not even have to think about infrastructure as code. So in some ways, AWS is acting a little bit like your platform engineer or your infrastructure as code expert and abstracting that away from app developers. You have something like Service Catalog, which many of you may have used, that would allow somebody who's building infrastructure as code templates to register those in a catalog of pre-approved IT services that are super simple for your app developers to use. Or something like Proton that I'll cover in a little bit more depth. And with Proton, we allow you to bring infrastructure as code templates together with your CI/CD pipeline to manage versioning and deployments over time and really think about that interface between platform engineering and application developers. Another trend that we hear about and are thinking about a lot is this GitOps approach to infrastructure as code. So the idea that in addition to managing your software application code in a central Git repository and then using a merge request process, issuing pull requests to update that, we're increasingly seeing that as a way to manage infrastructure as code itself. So bringing together a lot of the innovations coming out of Ben's team that we're seeing with CloudFormation and CDK, together with these best practices of Git versioning and pull request workflows, along with continuous integration and continuous deployment tools. And the reason that folks are doing this is because increasingly this allows you to automate standard processes. It provides a single source of truth, increasing your visibility and confidence in what's being deployed. So ultimately, your organization can be more agile, and you can also be more efficient. And efficiency is something that we're talking about a lot these days, making sure that with the people that you have and the resources available, you can do the most by automating and creating kind of a smooth path through this GitOps approach to your infrastructure. Sitting side by side with this are kind of these core tenets that we talk about. So single source of truth, making sure that you're controlling versioning, you're thinking about rollbacks for more secure and safe deployments, and ultimately all of your infrastructure can be run through these CI/CD processes. That will also bring a lot of benefits when Ben comes back to talk about governance and policy as code. So you can kind of see this as the foundation that then allows you to pull in more automation and more reviews to raise the bar on governance and security within your organization. Complementing GitOps is this theme of DevOps, which really has more to do with the way that your organization operates and a focus on introducing as much automation and smooth handoffs between your development team and operations team as possible. So some of you guys may be DevOps pros. Some of you may be here as part of a DevOps initiative to bring back best practices to your team. But ultimately, whenever we talk about DevOps with folks, it's because they're looking for more agility, so smoother change management, looking for more resilience, being able to automate processes, rollbacks, think more about this handoff when your operations team has an event. How can they quickly reach out to the developers who are involved? And then also being able to create standards that allow you to be more efficient and more secure over time. And the last piece that we're hearing a lot of folks talk about, and this kind of relates into the trend of increased serverless adoption, is the process of having application developers, because they're working more closely with your ops team, really influence the way that infrastructure is designed and deployed. So if you think about kind of the way that CDK is becoming much more popular, allowing maybe more application developers within your organization to write infrastructure as code itself, you also want to make sure that you have the right processes and checks in place. So something you could think about is, do you have a superstar set of application developers who want to influence infrastructure? They're really excited. They're starting to write infrastructure as code templates. How can you make sure that your platform team or operations team is supporting them and providing the right tools and deployment flows so that they can be safe and secure in bringing some of those changes to infrastructure as code into production? And ultimately, we're seeing these as things that, especially over the year ahead, will allow a lot of our customers to achieve their ultimate business goals of agility, productivity, and cost savings by starting to think more about how they can introduce platform engineering functions. Those folks can make it easy for everyone to take advantage of GitOps and DevOps. And ultimately, for application developers, also give them better, safe, and smooth paths to influence the way that their infrastructure is designed and deployed. So now I'll talk a little bit about how we're meeting this different balance of personas within AWS services and some of the features and areas that you can look if you're thinking about adopting some of these at your organization. And the first thing to think about is kind of what is the fundamental tool set and way that you're building and developing infrastructure as code, and does that reflect the kind of expertise and skills that your team has? And kind of thinking more about CloudFormation, maybe your team loves YAML, you love JSON, you're super happy writing CloudFormation directly. We're going to continue launching features and making that an excellent experience. But we also hear from customers who are increasingly using CDK, because that meets the needs of the persona who's actually writing infrastructure as code, or SAM for serverless. And you'll see these different layers of abstraction giving you different entry points as you think about how can I design the right infrastructure for my application needs and make sure that the people who have the best understanding and insights about what that infrastructure can look like have a tool that they like to use and are happy to develop with. And you'll see some of these recent launches are really exciting because they're meeting the needs of those individuals, and we're constantly listening to customers to have kind of better insights about what you're doing and how you're building. And the first thing that we wanted to highlight today was support for more language features in CloudFormation through this new transform functionality. So some of you may be CloudFormation super fans. You're excited to see Ben here. He's like a superstar because he does so much with CloudFormation PM. And he and his team got together, and they kind of had a discussion and engagement with different folks who were looking at building with CloudFormation and understand more of what their language needs and language asks were. And they recently launched support for different kinds of open language within CloudFormation, but the thing that's exciting is this kind of transform functionality within CloudFormation that will make it much faster for their team to support new kinds of language functions. So what you're going to see is a lot of this responsiveness and engagement from Ben and his team on that forum. Definitely encourage people, if you're using CloudFormation and have requests, to get online there and get involved. The other thing that the team's excited to highlight is kind of when we think about abstraction, being able to make sure that you understand how, if you're using CloudFormation to develop, that relates back to CDK and vice versa. So let's say that you have a mix of CloudFormation and CDK expertise within your organization. You've started to support teams who are using CDK more, and you start running into issues. And this is getting really hard for you to map because maybe something's been written in CDK, you go to deploy, that gets transformed into CloudFormation. And in the past, you may not have had as much visibility into the dependencies and relationship between the CDK you've written, the CloudFormation that's being deployed, and some of the error interactions that are happening there. So now with more support for this construct tree view that just launched, it's much easier for you to map the CDK that you've written to the CloudFormation that's actually being rendered and deployed. So that's a great example of how we're thinking a lot about different interaction points and kinds of expertise and personas who may be writing with infrastructure as code, and trying to provide you and your team with the right level of visibility to efficiently get infrastructure as code written and smoothly get that deployed and, if necessary, debugged. The other thing that I end up talking to folks a lot from the Proton side is the emergence of this idea of an internal developer platform. So let's say you're really happy, you've written a bunch of stuff in CDK, and you want to go and bring that to the rest of your team and organization. In the past, what you may have had is what we call ClickOps, where somebody gets on Slack and they Slack you, the platform engineering team or IAC expert, and they say, hey, I saw this template was available. Can you trigger that and deploy infrastructure for me? And you're sleeping because maybe you work across 2 time zones, and then it's Saturday, and you get back to the Monday, and you trigger the deployment and have to debug it. You don't necessarily have a great sense of business urgency. It's annoying. It takes a lot of time. So we're increasingly encouraging teams and talking to teams to help them move to more of a self-service model, where you can codify your infrastructure as code best practices and templates and create what we call kind of a golden path. So with this golden path, you've set up self-service templates, an interface that integrates with your CI/CD pipeline, and you've started automating more of the policies, governance, and security components of how you want applications to be deployed to infrastructure. And the benefit here is that it's faster for app developers. You can automate some of the work that your platform engineering team is doing, so you're spending less time responding to those Slack requests or tickets that are coming in. And you have a central visible point where you can look out and see what infrastructure has been deployed by whom when. And when it, kind of getting back to the idea in GitOps, when you need to have a versioning change or when you're trying to make a change to your infrastructure, it's much easier for you to go out and understand the state of the world. So ultimately, we're seeing IDPs as being a big trend within the DevOps space that will allow developers to move faster and platform engineers to do more. And specific to Proton, we've launched a few features this year that we think will be really exciting for folks who are starting to develop IDPs. One of them is support for a mix of different kinds of infrastructure as code tools. So in addition to CloudFormation, also being able to use Terraform, CDK, Pulumi. And we talked to a lot of customers where you might be part of an org where you acquired a company 2 years ago, and you're a Terraform tribe, and they're a CDK tribe, and you guys have historically been doing things differently. We're really seeing extensibility and flexibility as being key to helping both of those different communities and sets of skills within a larger organization work more efficiently and smoothly together. So this had been a big request from our customers, and we're excited to extend support to more different kinds of infrastructure as code tooling. The other thing is, as I mentioned, GitOps is becoming more and more popular. Thinking about how Git-based management of templates in Proton, you'll also see Service Catalog recently launched Git support, Glue launched Git support. A lot of these different services are allowing you to keep your application code in your preferred repository and have kind of more of a responsive and interactive experience from the AWS services that you're using. The last piece that I'll highlight and that we're thinking about and always curious to hear more on is trying to think about how we can let application developers who might be dipping their toes in experimenting with infrastructure as code influence templates. And with Proton, we specifically have a feature called components that allows developers to associate some infrastructure as code to a pre-existing template at deployment time. So the example would be, you all plan to build the perfect template that can cover all use cases. And what we hear is there's this horrible experience where you spent a bunch of time, you pulled all of your developers, you built something you think will be perfect, and a week after launching it, everyone needs like a different S3 bucket to be associated. Some people might need a database, and you go back, and before you know it, you have 1,000 different templates you have to maintain. So thinking more about how your tools can support the right core level of standards so you can achieve consistency without being so rigid that you're constantly having to introduce a lot of different variation that's hard to manage over time. So really what I wanted to leave you guys with today, before I kind of hand things back to Ben, is leaving this presentation and thinking, what is the right layer of abstraction for my team and the right set of tools to manage infrastructure as code? And you could come from a group where everybody spends all of their time writing YAML for CloudFormation and feels really comfortable setting up their own pipelines, operates really independently. You could also come from a team where most folks don't want to see infrastructure as code. They would prefer to use something like Amplify to deploy without having to interact with some of these resources that could be a little bit more complicated for them to pull together. A lot of folks we think are going to fall in the middle. And over the course of the coming year, one way that you can really supercharge your team is finding the right set of tools to map the expertise within your organization and think about introducing more automation, more guardrails, more golden path processes so that people can self-serve more, whether they're building with CDK, SAM, whether or not they want to consume things from Service Catalog, having that right mix of features and services in place to meet your organization's need. So with that, I am going to hand things back over to Ben, because one of the other really exciting pieces that folks start to benefit from is shifting a lot of governance left. So Ben, back over to you.
Thank you much. Quick show of hands. How many of you are standardizing on infrastructure as code as the primary way for managing environments? That's the common. OK, that's what I was expecting from this audience. And so as you're standardizing on that as being your kind of central place for doing any sort of deployment, it becomes very intuitive for that to be a place that you can start to enforce best practices. So these could be security best practices, compliance best practices, operational best practices, et cetera. So this idea of shifting left, policy as code, it's been around now for a while, but I'm starting to see more and more customers actually adopt this. And the way that we're looking at it is we have multiple different pieces of kind of I call it the three-legged stool. You have to have something that is actually your policy DSL. You have to have an actual control engine for preventative controls. You have to have a control engine for detective controls. And the top of that stool is who's actually writing the policies. And so the things that we've provided from our team, first and foremost, is an open source tool we call CFN Guard. And CFN Guard is it's a DSL, policy DSL, allows you to author policies that will go and scan your JSON configuration file. So it could be a CloudFormation file, it could be a Kubernetes manifest file, a Terraform state file, et cetera. And so it starts with how do you author these consistent set of policies that you can then extend out into all these different control points. Obviously, as Tatiana mentioned, you're building your pipeline, and a common place of doing that is kind of during the development time. You're authoring your infrastructure as code, you're scanning that using your DSL, your policy as code, you're ensuring that the best practices are enforced there. You deploy those through your pipeline. You probably have some sort of a check during that deployment process that, again, scans and ensures best practices, kind of failing fast, failing early in that development or the deployment process. And then you have what we launched earlier this year, something called CloudFormation hooks. And CloudFormation hooks actually acts as a managed control point for you. So now what you could say is, anytime I see this, let's call it an AWS S3 bucket being provisioned through CloudFormation in my account, I want you to stop that provisioning action. I want you to run my custom logic. It could be a policy, it could be a DSL. And we'll tell you if the properties of that particular resource meet my best practice. Maybe it's an encryption best practice. You want to look at the encryption setting and make sure it's set to AES 256, for example. And so we offer this as part of CloudFormation as this managed control point. The hooks execute right before CloudFormation actually takes that provisioning action. And then, of course, you want to have consistency with those policies in a detective nature. And this is something that's been around for a long time, right? We have services like AWS Config Rules or Security Hub, and these services are going to go and look at your live state resources and see if they comply with your best practices. Maybe something happened to change or someone circumvented your deployment. There's a break glass scenario. There was a change in your environment. Now you had some sort of a policy violation. So creating this really holistic approach to how you implement best practices, starting all the way during the kind of design phase or the deployment phase through to the actual preventative control point using CloudFormation, all the way through to kind of a detective-based control using Security Hub or Config Rules, et cetera. And this is already happening. This isn't just a vision, right? Config Rules announced support for authoring your custom policies using CloudFormation Guard. We're starting to see Security Hub use CloudFormation Guard. Of course, we launched CloudFormation hooks. And one of the things that we're excited to talk about today, it's actually something that was just launched yesterday in collaboration with the Control Tower team. They're actually making that prior slide that I just showed come to life. And what Control Tower did was they authored a set of controls, essentially, using CloudFormation Guard. And they did this for 28 AWS services. Now, this isn't a preview launch. So when you go into Control Tower, you can say, hey, I'm in this particular type of industry, or I have this particular set of control requirements or control standards objectives. You can now look at this library of opinionated controls that we've authored based on best practices, well-architected best practices, et cetera. And you can now extend those into preventative or proactive controls, we call them, in CloudFormation via CloudFormation hooks. You can also extend those to detective controls in Security Hub. So now you have this one place to go and say, I have specific control objectives I need to solve. We wrote those controls using a common DSL, CloudFormation Guard. We've extended those controls into CloudFormation, which is, as you all just raised your hand, is one of the common ways of managing and deploying your infrastructure. And then we also extended those same policies into detective controls using Security Hub, making that whole holistic kind of 360 control environment come to life. So it's a pattern we're seeing. It's a pattern we're definitely investing in. I had so many customer conversations just this week about shifting left and policy as code. And so it's an area we're definitely investing in, as I mentioned, with features such as CloudFormation Guard and CloudFormation hooks. Great. All right, so we talked a little bit about the past year. We talked a little bit about some of the things that we launched. Now what we want to do is just give a little bit of insight into directionally what we're thinking about for next year. So first on the list is coverage. I started this whole talk about our resource coverage. I talked about the importance and the strategic aspect of coverage, standardization. Our journey there is not done. We're going to continue to push for standardization, continue to push for resources to be migrated to the registry. As we do that, again, people will come to us and say, hey, why don't you fix this in drift detection? Why don't you fix this in resource import? Or it'd be really great if you had this in Cloud Control API. Our coverage journey and migration to the standardized model is going to solve all of those challenges, as I mentioned. We get resources on the registry, all of those features come to life. So we're going to continue to push for coverage. Second is performance. So oftentimes we hear, hey, CloudFormation is slow. Deployments take time. And there's pros and cons to that. We intentionally have some things in CloudFormation for safety deployments things like stabilization logic, et cetera. So in the performance section, we're looking at a couple different things. How do we help customers fail fast, improve the iteration, kind of the dev test cycle? How do we actually optimize the core engine of CloudFormation? And of course, how do we make sure that resources that are being deployed are kind of working at the most optimal speed? You may have seen some recent investments we made here. So we've tweaked some, the Lambda resource, for example. And we were able to make the Lambda resource quite a bit faster in just the last few months. So you start to see more and more improvements coming out of this in the overall theme of performance. The third one here is CDK. I mean, CDK is incredible if you look at the adoption of CDK. We have more than 1,000 contributors to the CDK open source project. Obviously, we have CDK for AWS. We have CDK for Terraform. We have CDK 8 Plus now to create your Kubernetes manifest. So incredible, incredible adoption of CDK. And we really need to make sure that we're enabling our customers to drive CDK adoption across the entire enterprise. So how do we do things like better manage the security boundary when you have to create specific roles, et cetera? So we're focusing a lot about kind of what we call crossing the chasm of helping customers adopt CDK across the entire enterprise. And finally, one of the areas that we really want to focus on is better deployment visibility. So today we have things like change sets. Again, we have drift detection. But as we evolve this resource model and we provide more consistency, we see a big opportunity to kind of better enable that whole GitOps story that Tatiana mentioned and do things like improving change sets, live change sets, being able to have a little bit more, provide you more confidence in when you're making a change to your infrastructure, you have the full visibility as to what that change will actually translate into when it hits your production environments. So we'll be doing more and more improvements around this area, providing visibility into what those changes look like. So that's year in review, that's year ahead. We hope you gathered something from this or take something from this session, something small, something big. We're going to go ahead and we'll stick around here. We have some time, so we have about 15 minutes. We'll stick around and ask any questions. But really, we just want to say thank you all for taking the time with us today. Hope, again, you learned something. Enjoy the rest of the week.